Um, so we'll start off today by sort of going through parallel lines, what they are, and the types of angles that you can find on them. Then we'll go through the properties of these angles and how you can use them to help you solve problems. And then we'll do some combined problems. So remember how we did angles on a line, angles in a triangle last week? So this week, we're just going to be combining parallel lines and triangles and things together. So hopefully it'll be a bit more challenging. So parallel lines are defined as lines which are always the same distance apart. So they're always going like this. So that means that they're also the same slope the whole way through. So the same like gradient or same angle, I guess, the whole way through. Because they're always the same distance apart, they're never going to meet. They're just going to go side by side like this. And when we represent them in diagrams, we often have these arrows. So the AB and CD, these two lines, they both have two arrows. So that means that they're parallel to each other. And then AD and BC, they both have one arrow. So they're parallel to each other. Here is a transversal. So you can have parallel lines and then you've got this line cutting through them at two distinct points. So that would be what we call a transversal. Oh, and when you sort of use notation in your reasoning for your geometric proofs, you can use those two slanted lines to represent parallel lines. So you can have these different kinds of angles when you have parallel lines and they're crossed by a transversal. So we can have corresponding. So if you look in this picture, the running dude, like there's two running dudes, they're on corresponding angles because you can see that they're kind of on the same position. They're both on this kind of angle on the lines. So this would be corresponding, same with the sleeping dude, the girl walking her dog. So that would be corresponding. They kind of just, it's kind of like a translation almost. It's like, it's on the same position, but on one line, and then another one, same position, but on the other line. And we can also have alternate. So these are angles that are between the parallel lines, and you've got your transversal cutting through, but they're both on different sides of the transversal. So here, once again, we have the running dude, and you can see that he's kind of like on, so one of the alternate angle pair is on the left side, or the bottom side, and then the other one is on top. And same with the kid on the floor. And now we have Cointeria. So Cointeria means that they're both on the same side of the transversal, which is like different from like alternates because they're both like angles that are in between the lines, but here they're on the same side of the transversal rather than different sides. So yeah. So I've got this little quiz for you guys now. Hopefully you remember the different types. It was a bit fast going through, but I'll see if you guys can annotate maybe. I annotate like that. Or if you've got any answers, just feel free to type them in the chat too. Yeah, good job, Amy. A, B, and C, D are the parallel lines. They've both got one arrow on them, showing that they're parallel to each other. Yes, nice. Yeah. Cointeria, T and R, yep. U and S, good job. Q and U, S and W. Yep, good job. And can anyone spot another pair of corresponding angles? Yes, nice, R and V. And well done, Amy. Wow. Yes, all of those are vertically opposite. So we talked about those last week, right? When you have two lines intersecting each other and the two opposite angles, so like this one and this one, they're like vertically opposite. Cool. Right, I'll just move on to the next slide now. Oops, what was that? Alrighty, some properties. Oh, I should get rid of the annotations. Sorry. Okay. So we have, as you could probably tell, we had corresponding angles and they looked about equal, right? And it does make sense because they're like lying on the same positions. So corresponding angles are always equal. And when you use this in your geometric proofs, you can use the reason that I've like highlighted over there. This one, oops. How do I annotate? Oh, this one here. So that is the reason that when you're like solving problems, you would use this. Cool. Next one. Oops. All right, and the same is true for alternate angles. So they are also always equal. And well, the annotation's a bit off, but the highlighted alt angles, parallel lines equal. And that is our notation coming in. So the two slanted lines, just it's an abbreviation of parallel lines. Last but not least, we have cointerior angles. And oh, I just saw a chat. Would you be able to let Diane into the meeting? Oh yes, I can do that. Oh yes, two people in the waiting room. Sorry, just admit. Oh, okay. All right, so we have our other type of angles. It's called cointeria. As we saw, it was like they're on the same side of the transversal. They're kind of facing each other. And what's special about these is that they always add up to 180 degrees. So if we have, and this is like a bit of a proof as to like why it works. So we can have A equal to C. We know that corresponding angles are equal, right? And then we know B plus C is also 180 degrees because of angles on a straight line. And because of this, we know that A and B must also add to 180 degrees because A and C are equal, right? So whatever C is being added to, A would also be equal. Sorry, that didn't really make sense, but yeah, A plus B is 180 degrees. Right, next slide. All right, so an important thing to know is that these properties, they only work if you've got parallel lines. So if you've got two lines like not parallel, then and you have a transversal going through them, then the angles that you form, they are not going to, the corresponding angles aren't going to be equal. and the alternate aren't going to be equal either. And the Cointeria would not add to 180. So that's just something to be mindful of. So for example, you have, oops, that's not a good line. So you might have like this, and you might look at this diagram and say, oh, there's corresponding over there, so they should be equal, but be careful because these two lines, they're not parallel, right? So it wouldn't work. Cool. Now here's a quick quiz for you guys. So we have which types of angles are equal to each other and which types of angles add to 180 degrees. So if you want to circle. Yep, nice. Vertically opposite angles are equal. Yes, alternate, good job. Cointeria add to 180, nice. And yes, corresponding angles are equal. Good job, everyone. Here's a bit of a video, a bit of a song that will, it's just like a recap of essentially all the different angle properties. It's got a few from that we learned from last week too. So I'll just, let me know if you guys can hear the sound, because I'm not sure if my computer audio is working. This video is going to play. So can you guys hear it all right? If you can, maybe give a thumbs up. In geometry, if you want to fare well, you need to know the parallel lines. They never touch, they're always the same distance apart. It's as if they don't like each other much, and there's only one thing that comes between them. Yes, a line that passes right through each of them. It's called the transversal, and it has several angle properties, just like these. Vertically opposite angles are equal, corresponding angles are equal, alternate interior angles are equal, co-interior angles equal 180. Vertically opposite angles are equal, corresponding angles are equal, alternate interior angles are equal, co-interior angles equal 180. Now before you try some geometry problems, you're gonna need some more knowledge to solve them. So listen closely up to these other helpful angle properties. See angles in a triangle or on a line add up to 180 every time. Angles around a point or in a quadrilateral are easy. They always add up to 360. Vertically opposite angles are equal, corresponding angles are equal, alternate interior angles are equal, co-interior angles equal 180. Vertically opposite angles are equal, corresponding angles are equal, alternate interior angles are equal, co-interior angles equal 180. For the next one, I'll pause it and then you guys can tell me which angle property the angles are. So angle 3 and 5, what types of angles are they? Yep, Cointeria. Good job, Trinity. Oh, I see Emmy's typed Cointeria in the chat as well too. Good job. Yes, the class does start at 7, but today we had some difficulties starting the meeting. So yeah, but it should start at 7 usually. Next slide. All right, here's some practice problems for you guys. So remember to use your angle properties, your alternate corresponding Cointeria. And once again, annotate, feel free to annotate. Yes, good job, Francis. Cointeria angles, adding to 180 right here. And when you write your answers, could you write your reason too, maybe in the bracket underneath? Yeah, good job, Trinity. Vertically opposite. Nice, yes, K is 120 degrees also. Yes, alternate for 125 degrees. Good spotting, Emmy. Yep, so we have two pairs of parallel lines, right? So you've got your horizontal ones and the slanted ones. So the horizontal pair, we can see that K and 120 are corresponding to each other, right? But then you've also got your other pair going slanting like this. So K and L are the Cointeria angles there. And yep, good job. Cointeria for I. Nice. Alrighty. And the next one. I'll just clear this first. All right, for X and Y, you might want to use some algebra to solve for them. Yes, good job, Trinity, VS 34. And could you also specify your reason? Yeah, nice, vertically opposite. Corresponding. I think someone's written down there 180 minus 34 equals 146. So there you would be using the Cointeria rules, but here I think it's just corresponding vertically opposite. So an important thing to remember, and it can get quite confusing, But the Cointeria, the ones where they're like facing each other, like on the same side of the transversal, those ones, they add to 180 degrees. And then the rest of them, like alternate, corresponding, vertically opposite, those ones are all equal. Yeah, good effort, everyone. Right, would anyone like to have a go at this maybe a bit challenging one with X and Y? $16. Yep, that is correct. So we've got our co-interior angles, right? So oh yeah, if you could write your working in, that would be really good too. Just to show everyone your thought process. Nice. Yeah, good job, Trinity. So I think another way, like, well, it's the same way. It's still using like algebra. You could have written an equation. But yeah, like what you did was like undoing the equation. So that's also good. I'll just see if I can annotate. So we could have set up an equation like 7y plus 68 equals 180. So that's just like using algebra. And then just as Trinity did, we would have to minus 68 from both sides. So to get just the y part, and then we divide both sides by 7. Yeah, good job. All right, anyone willing to give the X a crack? Yeah, nice. 41 and 139. And could you also explain your reasoning as well? But this question is a little bit trickier, so I'll give you guys a clue. So we've got these two parallel lines, right? And then we've got this transversal that's kind of like going through here. That. And we've got these two angles like this. So what kind of angles would they be? Oh, yeah, I see Amy's done Cointeria angles on the other side. Yep, that's good. X equals 12. Yeah, perfect. So X equals 12, and the way that you got it was because Cointeria angles, right? So we have 4x plus 11x, which we got was 15x. So they add to 180. And if we divide both sides by 15, we're going to get 12. Oh, I see that Aranxa has also said in the chat, x equals 12, so good job. And sorry if I'm pronouncing your name wrong. Please do correct me if I am. Alrighty. Let's do this now. We can probably slide. Oh yes, so parallel lines, you can see them in a lot of places in nature and in like life and like everywhere. So they're not just something that you see in geometry, you can actually apply them to a lot of different things. So here we have parallel electrical circuits. So if you guys have studied physics before, you will know that we make electric circuits for like light bulbs and things. Oh yeah, by the way, what year are you guys all in? Just wondering. If you like type it in the chat or something, just so I know like maybe how much physics you've done or maybe. Oh, you're right. Cool, cool. Oh, you know me from school, Emmy. Nice, nice. Year nine. Oh, we've got a range of ages here. Cool, cool. So maybe you guys have in class like played with those electrical circuits where you've got like lemons or something and you've got to plug like one side of the electric circuit in there. Okay, that's really random, sorry. So we have these electric circuits and we've got bulbs connected in parallel in these electric circuits. So, oh, cool, nice to know. So in class, you might have done this too. So you have like two different pathways. You've got like one battery, but you've got like two bulbs connected to it, and they're not just connected all in one circle with like two bulbs in a line like that. You've got like two different pathways. So these pathways are called parallel pathways, and they run, as you can see, like parallel to each other. And they're like different pathways for the electricity to travel through. So if one pathway, because if the bulb doesn't work, it means that electricity can't pass through the bulb. So if that stops working, then that pathway will be like broken kind of, but then the other pathways will still work because electricity can still flow through the other pathways. So yeah. And on the right side, we have parallel train tracks. So those are the rail ties, the wooden planks underneath the tracks. They're like across the parallel lines of the tracks, right? So those ones are kind of like the transversals because they're crossing the parallel lines, right? So yeah. Alrighty, combined problems. So these ones are a little bit more challenging because you will have to use like many different types of rules. So for example, in this question, we've got A, B, and C, and we've got to figure them out, but they've all got like different reasons. And so here we've got A, and we know that it's alternate to 81 because we've got these two parallel lines running like this. Oh, and by the way, a good way to remember kind of the shapes of alternate, corresponding, cointeria is I kind of like to think of it like you have alternate, which is kind of shaped like a Z because you've got these two angles and they're kind of like that. And then you've got corresponding, and that's kind of shaped like an F. And it's like, just do it over here. Oh, sorry, such a bad line. Got these two corresponding like that. So that's kind of like an F. And for cointeria, so what letter do you guys think cointeria angles look like when they're facing each other? Kind of like that. U? Yeah, U. Right, so you could say it's like U, like this. like facing each other. Or you could say it's like a C, either way works. Yeah, so those are Cointeria. Or you could even say it's like an N if it's like upside down. But yeah, so those are the different types of shapes that you get with these types of angles. So we've got a Z here, we've got alternate angles. So A is equal to 81. We've also got corresponding angles. So this one's a little bit trickier to spot, but we've kind of got, so in this diagram, there are two transversals, right? So this transversal here makes angle B and 43. So these two are corresponding and they're equal. Now we've got angle C, and we don't really have any like alternate angles or corresponding or cointeria that we can use for C, right? Because C is kind of just awkwardly wedged in between the two transversals. So that means that we've got to use some other rules that we know. And so we've got adjacent angles on a straight line add to 180 degrees. So we know that A is 81 and we've got 43 degrees there. So we can work out that C is 180 minus 43 minus 81, which will give us 56. All right. So now for more practice. Oh no, I'm still using the pen. Wait a minute. All right, so yeah, we've got some practice problems. So, oh, sorry, that box should not be there. I'll just move this over here, maybe a bit easier for you guys to write on. So remember, for these problems, we can use the parallel line rules, parallel line angle rules that we've learned today, as well as anything from adjacent angles on a line or angles in a triangle. Those will be really helpful for us. Yeah, N is 37. Good job, Trinity, because they're alternate, right? And 147. Oh, not quite, because we've got angle M and it's like on a line with 143. So we've got to be a little bit careful here because we've got 3 of these angles. They're all adjacent on the line. So 38, M, and 37. So all 3 of them add up to 180. Yeah, good job, 105. I'll just write this 37 back on here. At this point for angle L, you actually do have two different ways of working it out. So you could have the angles in a triangle, or you could have alternate angles, right? So often in geometry, you'll have like many different ways for solving the same problem. And like they're just as good as each other most of the time. So yeah, cool. All right, anyone got any ideas for angle A, B, and C on the right side? So for angle A, we've got these two parallel lines, right? And we've got this transversal here. So what could we use to help us? Well, we can see that this transversal has like these two angles. So it's got 175 and it's got A. So if you think back to what types of angles they are, they're like facing each other, right? And they're on the same side of the transversal. Oh, someone just said C is 158. Cool. And that's good. Right, so we've got C is 157 here. And how did we work that one out? Angles in a triangle, then vertically opposite angles. Yeah, good job, good job. Nice. Yeah. Another way you could have done it. So like, as I said, every way is just as good. It's just multiple different ways to get to the same solution. So you could have also, oh yeah, Emmy's just writing that there, 18. So you could have used A and B, so 5 and 18. And then you would have added 157 to make 180 in the triangle. Or as Trinity has done, she's figured out that this angle here is 5 degrees from alternate angles. And this one's 18 as we are given. So she knows that this one is 157. So the vertically opposite angle here would be 157 too. So yeah, both ways are just as good. So good job, everyone. Just going to move on to the next one. I'll just clear the. All right, some more problems. These ones might be a little trickier because you might need more than one step to work out each of the angles. $101. Nice, nice. Yeah, good job, Trinity, for showing you're working. Yeah, it's always really important to like show how we got our answers. All right, the one on the right-hand side might be a little bit trickier. So maybe we'll just do number 22 first, and then we'll go back to that one. But if anyone has any ideas. Oh, Trinity is already. Yeah, nice, nice. Okay. Oh, so this one, you might want to consider this angle first, and then that might help you work out E. So. Let me just draw this in. Yeah, so that was a clever guess at E plus 23 is equal to 41, but unfortunately, they're not quite like corresponding or alternate, because alternate means that they have to be like both inside the parallel lines. They have to be both in between, but this one's kind of like sitting on the outside and these ones are on the inside. But yeah, 26 is good, and that is because we've got angles in a straight line here, right? And we've got, so remember this square means that it's 90 degrees. So we've got 90, we've got 41. So the missing one is 49. And then we've got alternate angles. So we've got this angle right here is 49. So that means if this is 23, then E must be 26. So yeah, good job. All right, anyone have a crack at angle D? $296. Oh, I haven't checked the answer yet, so I'll just have. Oh, yeah, 296. Good job. So fast. Nice. Alrighty. Number 22. This one's a bit like more straightforward, I guess, because you can work them out straight from some of those rules. So have a go. So if you've got any ideas, feel free to annotate them, or if you can't annotate, you can also type them in the chat as well. $71, yep, good job, Trinity. And the reason is because I've got these two lines, and voila, I've got a Z right here, alternate angles, right? Nice. I'm just wary of the time. We're running a little bit low on time, so I'll just kind of speed through these questions. So we've got these two. These are alternate, so we, oh dear, I can't draw. Okay, so this is 23. And 86, 23, 86. Sorry, let me just check. Which one? Yep, 86, good job. And we've got angles in a triangle, right? Okay, onward. So next slide. Sorry, everyone. My laptop's just being a bit laggy. Right, so here we have some more, and we can use, so I'll just annotate. So we've got these two lines here. So they're in a triangle, right? Does anyone know what kind of triangle this is then? I think we did mention this last week, so see if you can remember. So does anyone have any idea? So we've got these two sides of the triangle, right? So the lines mean that they're the same. So if this triangle has two sides that are the same, what kind of triangle would it be? And 112. Good job. Yeah, exactly, isosceles. Because it's got two sides that are the same. And so that also means that it's got two angles which are the same, right? So could someone mark which two angles on this triangle are the same? Yeah, nice. So these base angles are the same, right? So we've got 68 over here too. And this will be helpful in helping us figure out angle B. So we've got alternating angles. So angle B is also 68, right? And how about angle A? It's also 68, right? So everyone's 68 here. Now angle C, you might be tempted to say that it's 68 too, because everything seems to be 68. But we've got to be a little careful. We've got a few more steps to figure out. There we go. To figure out angle C. So does anyone know? 44 degrees. Yeah, 44 degrees is good. And how did you figure that one out? Yeah, nice, nice. So first we've got angles on a line, then we've got vertically opposite angles. So 2 steps to figure out C. Cool. All right, so we, let's see. Angle. So we know these two. Right, here's a clue. So to figure out angle S, nice, because we use corresponding angles, right? Yep, so 68 over here, because of angles on a line. All right, so what would T be? So I've got this triangle around the outside, right? Yeah, 65, nice. Alrighty, so for this next one, it might be a bit more confusing because of like the different lines all sort of mixed up together. So I'll just color code it. We've got these two. They've both got 2 arrows, so that shows that they're parallel to each other. And we've got these two. I might just extend them a bit so it's a bit clearer. And by the way, this is an isosceles triangle, as we can see from the lines. Sorry, I might just undo my stuff. I think it made the diagram look even more confusing than it was at the start. Okay. Okay, so to start this question off, we can't figure out these angles straight away. So what we've got to do just mark this out first. You know, geometry, like it's a bit hard to get started on problems sometimes because you can't always see, like, it's not very obvious which one you need to work out first. So it's a good idea to sort of go around the diagram, labeling whatever angles you can figure out, even if it's not the one the question's asking for. So for example, this one, you know that from corresponding angles that this angle is equal to 32 degrees. And while it might not be in the question, it's actually going to be quite helpful for us. So this angle right here, I've got corresponding angles. So could anyone maybe write in what angle this is? Angle XDE. Yep, 32. Good job, Trinity. 32. Alrighty, so we've got this isosceles triangle here. So what are some other angles that we'll be able to figure out? How about angle XED? Anyone got any idea? So it's isosceles, right? So we've got these two sides are equal to each other. So we've got the base angle. Surprised face. So this angle here, we would have 32 degrees as well, right? Because isosceles triangles, so their base angles are always equal. So this angle here, could someone tell me what this angle here is? It's in a triangle, right? And we already know two of those angles are 32. So what would the other one be? $116. Yes, nice. 116. And that's because we know that the angles in a triangle add up to 180 degrees. And we've been slacking a little bit of notation, so I just might remind you guys. So this is how you would write the reason. Angles in, and mathematicians are like lazy people, so they don't want to write the whole thing. So they kind of abbreviate it to angles in triangle add to 180 degrees. Right, I'll just speed through this next part. It's quite a challenging thing. So it's like an extension thing if you want to like do it. Just annotate. Right, so here we are given a diagram. However, just from this diagram with the lines that they've given you, you can't figure out D straight away. So because like D is kind of like wedged in between these two lines and it's not really like alternate to like this one. It's not really alternate to this one. However, we can make it alternate by adding this line here. So if we make this line, it's parallel to the other two lines. So like all three lines are parallel to each other. So now all of a sudden we've got 26 here. So this must be 26, right? Because they're alternate. And we've got 43 here. So this one must be 43 also because of alternate angles. 43. And the angle that we wanted to find was this big one. So if we add 43 and 26, we're going to get 69 degrees. And what they've done here is they've like labeled each half of the angle. So they've labeled this D1 and this D2. So you can do that as well to make your working a bit more clear as to which angle you're figuring out. All right. I just move on to this last slide and then we'll have a Kahoot. So feel free to like leave if you're like, if you've got other commitments, but if you want to stay for the Kahoot, that would be great. So now I've just got 2 last questions before our Kahoot. Now, I'll just annotate again. Now, could someone draw in maybe a line that will help us with the question on the left? It's kind of like the example question, right? Where we've got Z here, but we can't really figure it out from what we've been given. You guys are feeling a bit shy. So I'll turn off the names of the annotators. So that means that if you write something on the board, no one will be able to see who it is. So you can all write completely anonymously on the board if you like. Anyone? All right, I'll do it then. So it's this line right over here. Oh, I've drawn it quite badly, but okay, we can just pretend that it's a beautiful straight line parallel to everyone else. So this is the line that we would draw. And now we've got to have, oh yes, 82. So 82, how did you figure out 82? Maybe write a reason in there. So we've got to be a little bit careful. So this is a very easy trap to fall into, is when you see like 2 lines and they've got like sort of angles within each other, that they're Cointeria, but they are Cointeria, but because these lines are not parallel, we can't use the Cointeria angles add up to 180 degrees rule. So like this here, because these 2 lines are not parallel, so unfortunately we can't use it, but good try. So what we actually want to do is maybe we can do, so I think as you already wrote, this one is 98, right? And $82, yep. Mm-hmm. 57. Yes. Oops, sorry. I rubbed off a bit more than I wanted to. Okay, so I think you wrote this one was 57. So now we can figure out h, because we've got, now these are cointeria angles between parallel lines, right? Because we've got these two big lines running and they are parallel to each other. So that means that these ones, they do add up to 180 degrees. So angle H would be, what would it be? Anyone got any idea? So we know that they add up to 180, right? Because they're cointeria. All right, so it's 123 and 57 add up to 180, right? Just being aware of the time, I'll just quickly go through this example here. So this example, we've already drawn in this line, so we can use our parallel, because it's parallel to all the other lines, so we can still use our parallel line rules here. So we've got this one right over here. Oh, this does not match up. Let me just, okay. Oops. Yeah, I'm not a very good artist, as you can see. So I've got this one right over here. Oh no, why is it orange? Okay, that's all good. So we've got this one right over here. And we've got these cointeria angles, right? So this half of the angle would be 141, because 180 minus 39 is 141. Right, and then we've got this half. So we can still use cointeria angles, right? So could someone tell me what this half of the angle would be? So Z plus 28 is 180, right? Anyone? All right, Sunday night, maybe we're a little bit tired, so I'll just write that in then. We've got 152. Ta-da. Okay, so now we've got 141, 152. So this whole angle would be 293. Okay, now we have finished with this slide, and we're gonna do a Kahoot now. So if you want to join, feel free to join. Otherwise, thank you for coming.